Hello, hope you're doing well. We are here starting your first of the videos for your Algebra 2 class, looking at section 1.1, so hopefully you've got your notes packet out with you. Right here on the front page should say these kinds of things. And I'm going to start talking about real numbers, number operations, some of the basics that we're going to be using over the next few months of your life. We're always going to start out here with your objective, essential question. These are just kind of fancy teacher things that we put in here. But they do help in letting you see what it is that you're going to be looking at. We're going to be looking at different subsets of the number system and that kind of thing. Also down here has got the problems in your practice packet or your homework packet of all the types of things that you're going to be doing on your quizzes and your tests based on the work that we're doing right now. So those are good examples to go look at and work out on your own. So vocab, opposite just means the negative of something. So like a 5, the opposite would be -5 or vice versa, back and forth. Your reciprocal means it flips over. So 5 is really a 5 over 1. When you flip it over, it becomes 1 over 5. Same thing with like a 2/3. You flip it over, it becomes 3 over 2. So that's what a reciprocal is. I'm not going to do much with them right now, but eventually we're going to be using these words a lot and doing a lot of things with them. Commutative property, associative property, these are things that you probably dealt with a lot in geometry class, did a little bit in your algebra class before, big proficiency words, things on the proficiency test. Um, your commutative property really just says, 3 times 2 is the same as 2 times 3, or 5 plus 8 is the same as 8 plus 5. Doesn't matter what order you write them, they work out to be the same. Your associative property is kind of the same idea. If you got 3 things you're adding, it doesn't matter whether you add these ones first or these ones first, it's going to come out the same. And same idea with multiplying. Whether you multiply the back 2 or the front 2 first, it doesn't matter, you're multiplying all 3. Distributive property. This is where you take that front thing and you multiply both things on the inside, everybody gets an A. Probably your favorite property from Algebra 1 that you do all of the time. Distribution just keeps happening all year long. And we're going to do some examples of those kinds of things a little bit more probably tomorrow. Alright, our set of numbers. I don't know why this is all the way down here like this. Sets of numbers. These are all the different types of numbers. As we go down, it's kind of like they're getting more and more complex and more things going on. So natural numbers, these are the first ones you learn when you're a kid. If you're watching Sesame Street and the count, going through the numbers, 1, 2, 3, 4. Those are your natural numbers. Then the next thing that we add is 0, and so those become whole numbers. Whole numbers with the 0 in the middle there are when we add 0 to the equation. And it's kind of amazing how long it took before people doing any kind of math started accepting 0 as an actual number. We figured out the Pythagorean theorem and all kinds of crazy things, the distance around the earth, all this stuff, and then finally somebody was like, hey, what about nothing? Nothing is something. We should make a number for that. So it took a really, really long time before we had a number actually at 0. Integers. Integers are when we add in negatives. Um, so that's the only difference. Whole numbers are just the positive version. Integers are both negatives and positives. Rational numbers is when stuff gets a little more interesting. Anything that can be written as a fraction, like 1 over 2, or 0.333 repeating, is the same thing as 1/3. All of those things that can be written as a fraction are rational numbers. I always remember it because the beginning of this says ratio, and a ratio is just a fraction. So if you forget about this part, it's literally saying ratio numbers, which means fractions. If something cannot be written as a fraction, that's what's called irrational. Those are crazy. They are not rational numbers. Irrational things would be kind of like pi is irrational. 3.14, it goes on forever. It doesn't have a pattern. If you did Pi Day back in your geometry class, you probably memorized more numbers from it than I did. Um, but any decimal that goes on forever without a pattern is going to be what we call irrational because it cannot be written as a fraction. So pi, square root of 3, square root of 5, any of those weird square roots that we don't really know the answer of, those are all what we're going to be calling irrational numbers. And real numbers are just sort of all of the above. Everything up here is all real. It exists. What's the only number we're going to talk about all year that doesn't exist? I. I is imaginary, and it equals the square root of -1. We don't know what the square root of negative 1 is. It doesn't make sense, so we made up I and said it's imaginary. We're just pretending. And obviously, if we're just making it up and it's imaginary, it ain't real. So, unless we ask you about I on the test, which we won't, everything that we're going to ask you about is going to be real. And don't worry, we'll talk about I later this year. So, here's your Venn diagram-y kind of thing going on. With all your nested groups, your natural numbers are like 1, 2, and 3. Your whole numbers, when you get to 0. Integers are things like -1 or -2. Rational numbers are when you start getting into fractions. Irrational numbers are your pi and your square root of 5. Your real numbers are all of these, and the only guy on the outside is I, and he's sad because he's not real. I just want to be a real number. Alright, so the types of questions you're going to get on your test. We're going to decide, is this number real? Well, yeah, we're going to circle real every time. So the next real question is, can it be written as a fraction, or can it not? Square root of 3, can it be a fraction? No. So it's irrational, and we don't even worry about the rest of that stuff. Because if it's irrational, it can't be anything else. Square root of 4, what does that equal to? Hopefully you think, it's 2. So we're going to choose real, and now we decide, is it rational? Yeah, it is. Alright, so now how far back does it go? Is it a natural number that they would count to? Yep. So then we get all the rest of these. -7. Well, it is real. Can it be written as a fraction? Yes, it can. Is it a natural number, though? No, -7 is not on Sesame Street. It is not 0. And therefore, it just is an integer. It's an integer. Negative numbers are integers. 1, 2, 3, 1, 2, 3, 1, 2, 3. Is there a pattern? Yes, there is. It starts at 1, 2, 3, and it repeats forever. So that means it's real and it is rational. Because if it repeats, it can be written as a fraction. Does that mean it's any of these other things? No. Alright, 29. Definitely real. Can it be written as a fraction? Yes. How far back does it go? Well, if was it be on Sesame Street? Yeah, eventually you can count up to 29, right? So that means it gets all of these guys. Last one here, 0. 0 is real. It is rational. Is it natural? No. It is a whole number, and therefore it is also an integer. So there's all the different types of questions you might get. Definitely want to make sure you pay attention to those, because one of your test questions will be one of those. Alright, so last little bit that we're going to look at here is just changing our crazy words into math. You're going to get a lot of different word problems and stuff in class, and different types of things throughout the year, so you've got to be able to take the words and translate them into what the math means they're going to do. So here, the difference of means subtract two different things, something here and something here. What are they? 3 times x and 4. So whenever it says the quotient of, the sum of, the difference of, whenever it says those types of things, where the and is always kind of splitting this thing and this thing, and we put our subtraction sign in the middle. So 3x minus 4 is greater than, that's this symbol, and 12. So 3x minus 4 is greater than 12. Alright, 5 times x is, so that means 5x equals 32 more than, so I'm going to take something and I'm going to add 32 to it, more than twice x, that's 2x. There you go. The quotient of means we're going to divide 18 and x, so 18 and x equals 6. Quotient of, that means we're dividing here, 18 and x. Alright, the sum of this and that, what is the this? 2x and 7 is equals 19. Nice, but you're going to want to make sure you pay attention to the difference here between number 10 and number 11. They're close. Twice, that means 2 times, the sum of this and that. So those things are going to go in parentheses. Twice the sum of this and that. X plus 7 equals our 19. So the difference here is twice the sum of versus the sum of 2 times. Whether the 2 goes on the outside or on the inside. And lastly here, 9 subtracted from. That means something gets minus 9. 4x. So 9 subtracted from 4x is equal to 100. And with that, we are done for the day. You have finished your first Algebra 2 notes video. It wasn't so bad. So, hope you make some good choices out there. Make sure you show up to class. It's always good. And we'll see you on the next video. Take care. Bye.